Something is happening to the Mississippi River that, by every rule we know, should not be happening. This isn't a rumor. It's not a theory floating around online. It's not a prediction about the future. It's happening right now. Along sections of the river near Lake City, people have been walking down to the shoreline and stopping in shock. Hundreds of fish, sometimes thousands, floating lifeless on the surface. Entire stretches of water look wrong. Too warm, too shallow, too still. Biologists confirm that sudden temperature spikes and low oxygen levels are triggering mass die-offs. But the fish are just the most visible sign of a much larger problem. Up and down the Mississippi River system, gauges are flashing numbers that engineers have never seen before. Barges are being forced to carry lighter loads. Shipping schedules are slowing. Supply chains are stalling. Tourist towns that depend on river traffic are watching business dry up. And all of it points to one impossible reality. Water levels are dropping to historic lows. But here's where the story takes a turn. This isn't just a drought. Yes, the Midwest has been dry. Yes, rainfall patterns have shifted. But drought alone does not explain what scientists are seeing. Nearly half of the Mississippi River, America's most important river, appears to be vanishing. Not evaporating, not being diverted into canals, not stored behind dams. Simply disappearing. Between Illinois and the Gulf of Mexico, monitoring stations are reporting a loss of water so massive it breaks the basic math of hydrology. The numbers don't balance. The amount of water entering the system upstream does not match what's flowing out downstream, and the gap is enormous. To put this into perspective, the missing volume rivals the entire annual flow of the Colorado River. That's not a rounding error. That's a crisis. Scientists aren't just confused, they're alarmed. Because this river isn't just scenery. 18 million Americans rely on the Mississippi River for drinking water. Tens of millions more depend on it indirectly for food, fuel, power, and commerce. And right now, no one can fully explain where the water is going. To understand how this could happen, we have to step back and understand what the Mississippi River really is and what we quietly turn it into. The Mississippi is not just a river. It's the central artery of an entire continent. It drains 41% of the continental United States. Water from 31 states and 2 Canadian provinces eventually funnels into this single system. Snowmelt from the Rockies, rainfall from the Midwest, runoff from farmland, forests, and cities, all of it ends up here. Every single year, more than 500 cubic kilometers of water move through the Mississippi River system, making it one of the largest on Earth. That water carries nutrients, sediment, and life itself. For centuries, the river behaved in ways people came to understand. It flooded in spring. It pulled back in summer. It followed rhythms that farmers, traders, and engineers learned to trust. Entire economies were built around that trust. Over 500 million tons of cargo move down this river every year. More than 90% of U.S. agricultural exports depend on it. A single barge tow can replace nearly 900 semi-trucks, moving goods more efficiently than any highway ever could. The Mississippi doesn't just move water. It moves corn, soybeans, wheat, fuel, chemicals, steel, and energy. It feeds cities. It supports wetlands. It holds back the sea. But something has changed. Upstream gauges still show relatively normal flow. Downstream gauges show collapse. The river looks fine in one place and broken in another. And the difference between those readings is so extreme that it defies explanation. At first, engineers assumed faulty sensors. Instruments were recalibrated. Data was double-checked. Alternate measurements were brought in. The numbers didn't change. The water was still missing. And that's when researchers began asking a question no one wanted to ask. What if the Mississippi isn't losing water on the surface? What if it's losing water below? To answer that, we have to go back nearly 100 years to the disaster that reshaped the river forever. In 1927, the Mississippi River did something that terrified the nation. It overflowed. Not a normal flood, not a seasonal surge. This was the most devastating river flood in American history. More than 27,000 square miles were submerged. Entire towns disappeared underwater. Hundreds of people died. Over 500,000 were displaced. Many of them poor black farmers who were never fully compensated for what they lost. The flood exposed a hard truth. The Mississippi River could not be controlled with piecemeal levees and local fixes. And so, the federal government stepped in. In response, Congress passed the Flood Control Act of 1928, handing near total authority over the river to the U.S. Army Corps of Engineers. What followed was the most ambitious river control project ever attempted by humanity. Thousands of miles of levees were constructed. Dams and locks reshaped tributaries. Channels were dredged and straightened. Concrete embankments replaced natural banks. The goal was simple: stop flooding, protect cities, and make navigation predictable. And for decades, it worked. Floods were reduced. Shipping became reliable. Insurance rates stabilized. The Mississippi was transformed from a wild, shifting force of nature into infrastructure. But rivers are not machines. And when you force a living system to behave like one, consequences don't show up immediately. They accumulate quietly over generations. By imprisoning the river between rigid walls, we changed its physics. Confined water flows faster. Faster water cuts deeper. And when a river is cut off from its natural floodplain, it loses access to sediment, the material that once rebuilt its bed after every flood. For decades, the Mississippi began eroding itself downward. At the same time, massive dams on major tributaries, especially the Missouri River, trap hundreds of millions of tons of sediment upstream. The lower Mississippi was being starved. Engineers began noticing odd discrepancies. Water entering the system wasn't arriving downstream in the same volume. At first, the difference was small. Then it grew, month after month, year after year. Still, no one could explain it. So scientists looked beneath the river itself. What they found shocked everyone. Core samples taken from the riverbed revealed that the Mississippi had lost its natural layering. The clay and compacted sediment that once acted as a waterproof barrier were gone. Decades of erosion had stripped them away. In their place was a highly permeable mix: sand, gravel, fractured layers, more like a sponge than a sealed channel. The river was no longer sitting on a solid foundation. At the same time, another force was pulling from below. Beneath the Mississippi lies the Mississippi Valley Alluvial Aquifer, one of the most important groundwater reserves in the United States. For decades, it has been pumped relentlessly to support industrial agriculture. In some areas, groundwater levels have dropped dozens of feet. That created a powerful pressure imbalance. Water always moves from high pressure to low pressure. And now, the river, once dominant, was sitting above a depleted underground system that was effectively sucking it downward. What scientists were witnessing had almost never been documented at this scale. A continental scale hydraulic leak. The Mississippi wasn't just flowing south anymore. It was draining into the earth. As river volume declined, the consequences appeared fast. In Louisiana, salt water from the Gulf began pushing upstream. Normally, the Mississippi's force keeps the ocean at bay, but weaker flow meant less resistance. Drinking water supplies for nearly 1 million people were threatened. The Army Corps rushed to build underwater barriers to block the salt wedge. The cost exceeded $20 million, and the fix was temporary. Barge captains watched channels become unpredictable. Sandbars formed overnight. In 2022 alone, more than 2,000 barges were stranded, sending freight rates soaring and profits collapsing. Fish died as water warmed. Mussel beds vanished. Wetlands shrank. Migration routes failed. This wasn't one disaster. It was an entire system unraveling. Official reports use cautious language, but the conclusion was brutal. The Mississippi has entered a regime shift, a fundamental change in behavior. Adding more water doesn't fix it. It drains faster. Reducing pumping shifts the pressure elsewhere. Rebuilding sediment layers could take centuries. The river didn't break physics. It followed them. For 100 years, we believed we had mastered the Mississippi. What we built instead was a system optimized for short-term control and long-term instability. And now, America's circulatory system is bleeding into the ground beneath it. The gauges are still watching. The numbers are still falling. And the real question isn't whether the river will find a new equilibrium. It's who will pay the price when it does.